some of the science is actually on the outside of the station, like this payload called the alpha magnetic spectrometer. And it's studying very fundamental properties of our universe and trying to understand more about antimatter and dark matter. And then inside the US laboratory, you can see we have all different kinds of science equipment. And so we can do a whole variety of different kinds of experiments. In this one in particular, they're trying to study combustion in space and learn more fundamentally about flames and combustion. So a physics experiment. And here you have an experiment trying to understand how liquids move in space, particularly in small channels, so it's called capillary flow. That's how you can get propellants to engines in microgravity. Here we have some kind of small satellites that students can actually program to do different kinds of maneuvers, and useful for understanding more about satellites that we have in space. We also have a 3D printer on board, and so we can actually print spare parts now for certain pieces of equipment that we have in space. This is an experiment we used to have up there that measured the direction of wind on the surface of the Earth, particularly on the surface of oceans. And so you can add it to other observations and understand more about storms and more about weather forecasting. We also deploy a lot of CubeSats. Some of these are built by companies, some by universities. We've even had one built by an elementary school that we deployed into space. And then we're trying to learn more about how we'll do future space exploration. This is an inflatable module that we have attached to the space station now. We developed that inflatable technology at Johnson Space Center a number of years ago, and then we licensed it to a company that's now building habitats. We've also been able to grow food on the International Space Station, different kinds of lettuce, something that we think, again, is going to be important for future space missions. And we have to keep astronauts healthy, so they spend a couple of hours a day exercising, and particularly using resistive exercise devices, which really helps with the bone and muscle mass. We had astronaut Scott Kelly about 2 years ago. He spent a year on the International Space Station along with cosmonaut Mikhail Kornienko. And that was part, again, of understanding about human health and performance in space and how we can do much longer missions, for example, someday when we go to Mars. Good view of Scott in the cupola, which is probably the favorite place of astronauts to hang out because of the beautiful windows and the view they have of the Earth. Another good view of the Middle East with the Nile River and the Gulf of Aqaba. A view of Aurora from space, which is really spectacular. You have amazing views of storms, hurricanes, and just all different kinds of phenomena. We get supplies up to the station in a variety of ways. This is a SpaceX vehicle called the Dragon, and this is a vehicle called the Cygnus, developed by another company called Orbital ATK. They bring up supplies. This is a new spacecraft that's being developed to take supplies to the station by the Sierra Nevada Corporation called the Dream Chaser. We're also working with two companies to develop new spacecraft to take our astronauts to and from the space station. This is the Boeing company is developing a vehicle called the Starliner, and we hope to have its first test flight next year. And then SpaceX is developing a vehicle called the Crew Dragon. Also hopes to have it for its first test flight next year. So that's some of what's coming up for the International Space Station, which I hope you all will follow along. Then we're also developing a new spacecraft to go beyond low Earth orbit to the moon and beyond, called the Orion. And this rocket, the Space Launch System, will be the one that launches it. And we plan to have the first test flight with both the spacecraft and the launch vehicle in 2019. Won't be people on board this craft because we want to test out the systems first, but the second time it flies, we'll have people on board. And I hope all the students and parents and everyone in the community will follow along over the next few years as we're developing all these new ways of exploring space. So thank you for following along, and let me know how much time we have.
We can take questions for 5 minutes.
Okay, we have a few minutes for questions if anybody has any questions they'd like to ask. Yes? So it says, how long does it take us to get to space? Well, from the time we start the launch till the time we're going at the speed that allows us to be in space, it's about 8.5 minutes. And then about 30 minutes later, we need to do another engine burn, and that gets us in orbit around the Earth. So it doesn't take very long. Yes? Is it hard to control the robotic arm? Well, you have to spend some time learning it. You have to learn how it operates, and then you have to learn how to use the hand controllers, and then sometimes you have to think about, well, something might not work right, and so you learn sort of different ways of operating it depending on whether all the equipment's working or only part of the equipment's working. So you spend a lot of time in classes and working a simulator over a couple of years or so to get to be prepared to go into space. Yeah. Can you say that again? How did the sun get bright? Well, if in your science class you may learn a little bit about stars, but it has hydrogen and helium, and there are processes that make the sun really hot, which is what makes it bright. Yeah. How did it feel on my first mission? Well, it was pretty exciting. The launch is definitely the most exciting part. There's a lot of acceleration involved in that. But then, as I said, after 8.5 minutes, all the engines cut off, no more fuel, and so you're floating at that point, and you have to get used to working and living in an environment where you're floating and everything that you're working with is floating as well. So it's a really different way of living and working than you're normally used to on Earth. So it takes some time to get used to it. Let's see here. You've had your hand up for a while. How did it feel to be floating? Well, did it look like it was kind of fun? Yeah, it is fun. Some things are harder and some things are easier. So one of the things that's easier is if you have something that you're moving, let's say, that on Earth would be really heavy, like maybe it weighs a couple 100 pounds and I would never be able to move it on Earth. Well, in space, it's floating. So it's actually possible to move it pretty easily. What you have to worry about is stopping it moving, though, because that takes a little bit of force. But then some things that are harder, like if you're trying to repair a piece of equipment and maybe you have 3 or 4 different tools, and on the ground, you could lay all those tools out in front of you on a table or something, right? And just pick each one up as you needed to use it. Well, in space, if you do that, they just float away. So we have to have Velcro on everything. You have to be very methodical and Velcro things down so they don't float away and you lose the things that you're working on. Yeah. Mm-hmm. Do I speak any other languages? Unfortunately, no. I mean, I know this much Spanish, I know this much Russian, but I can't really have conversations. I can mostly I can read a little bit and, be able to read signs and things like that. But being able to speak different languages is important for astronauts. All of our astronauts who go to the space station and stay there have to learn Russian. And we do work with astronauts from around the world, so the more languages you know, the more you're able to converse with all these other people that we work with. Yeah?
On the video, I saw boxes that were dropped into space.
Yeah, the CubeSats.
What are those?
Those are little satellites. They're only about this big, but they all have some kind of science or engineering demonstration, or they're trying to learn something. Sometimes they're programmed in a way that allow students to learn how to program, and they can be in a specific trajectory. Other times they have sensors, and they might be studying something about the environment that they're in up in space. Yeah. Yes. question is, who encouraged me to go to outer space? Well, the space shuttle flew for the first time when I was starting graduate school, and I was studying to be a research engineer. And the shuttle was just this amazing vehicle that allowed you to do all different kinds of experiments. So the astronauts who were on board that in the early shuttle missions were really the ones that inspired me. I got to see, watching on TV, the first American woman to go into space, Sally Ride. And that certainly made a big impact on me. Maybe like 2 more questions. We can get one at the end. Yes, did you have a question? No, I didn't go on any of the Apollo missions. Those happened when I was maybe your age, so I got to watch them on TV. And it was very, very exciting, and that was certainly one of the things that got me interested in space. And how about last question?
Why the sun is hot inside and it's really hot?
Is it hot at the sun? Yeah, absolutely. Fortunately, we're not really any closer to the sun when we're in space than we are here on Earth, or it would just be too hot for us.